Physics is the natural science that studies matter, its motion and behavior through space and time, and the related entities of energy and force. Physics is one of the most fundamental scientific disciplines, and its main goal is to understand how the universe behaves. Physics is one of the oldest academic disciplines, and through its inclusion of astronomy, perhaps the oldest, over much of the past 2 millennia, physics, chemistry, biology, and certain branches of mathematics were a part of natural philosophy. But during the scientific revolution in the 17th century, these natural sciences emerged as unique research endeavors in their own right. Physics intersects with many interdisciplinary areas of research, such as biophysics and quantum chemistry, and the boundaries of physics are not rigidly defined. New ideas in physics often explain the fundamental mechanisms studied by other sciences and suggest new avenues of research in academic disciplines such as mathematics and philosophy. Advances in physics often enable advances in new technologies. For example, advances in the understanding of electromagnetism, solid-state physics, and nuclear physics led directly to the development of new products that have dramatically transformed modern-day society, such as television, computers, domestic appliances, and nuclear weapons. Advances in thermodynamics led to the development of industrialization, and advances in mechanics inspired the development of calculus. Ancient astronomy. Astronomy is one of the oldest natural sciences. Early civilizations dating back before 3000 BCE, such as the Sumerians, ancient Egyptians, and the Indus Valley Civilization, had a predictive knowledge and a basic understanding of the motions of the sun, moon, and stars. The stars and planets, believed to represent gods, were often worshipped, while the explanations for the observed positions of the stars were often unscientific and lacking in evidence. These early observations laid the foundation for later astronomy, as the stars were found to traverse great circles across the sky, which however did not explain the positions of the planets. According to Asker Abo, the origins of Western astronomy can be found in Mesopotamia, and all Western efforts in the exact sciences are descended from late Babylonian astronomy. Egyptian astronomers left monuments showing knowledge of the constellations and the motions of the celestial bodies, while Greek poet Homer wrote of various celestial objects in his Iliad and Odyssey. Later Greek astronomers provided names which are still used today for most constellations visible from the northern hemisphere. Physics in the medieval European and Islamic world. The Western Roman Empire fell in the 5th century, and this resulted in a decline in intellectual pursuits in the western part of Europe. By contrast, the Eastern Roman Empire resisted the attacks from the barbarians and continued to advance various fields of learning, including physics. In the 6th century, Isidore of Miletus created an important compilation of Archimedes' works that are copied in the Archimedes Palimpsest. In 6th century Europe, John Philoponus, a Byzantine scholar, questioned Aristotle's teaching of physics and noted its flaws. He introduced the theory of impetus. Aristotle's physics was not scrutinized until Philoponus appeared. Unlike Aristotle, who based his physics on verbal argument, Philoponus relied on observation. On Aristotle's physics, Philoponus wrote, "But this is completely erroneous, and our view may be corroborated by actual observation more effectively than by any sort of verbal argument. For if you let fall from the same height to weights of which one is many times as heavy as the other, you will see that the ratio of the times required for the motion does not depend on the ratio of the weights, but that the difference in time is a very small one. And so, if the difference in the weights is not considerable, that is, of one is, let us say, double the other, there will be no difference, or else an imperceptible difference, in time, though the difference in human weight is by no means negligible, with one body weighing twice as much as the other. Philoponus' criticism of Aristotelian principles of physics served as an inspiration for Galileo Galilei 10 centuries later. During the scientific revolution, Galileo cited Philoponus substantially in his works when arguing that Aristotelian physics was flawed. In the 1300 seconds, Jean Buridan, a teacher in the Faculty of Arts at the University of Paris, developed the concept of impetus. It was a step toward the modern ideas of inertia and momentum. Islamic scholarship inherited Aristotelian physics from the Greeks, and during the Islamic Golden Age developed it further, especially placing emphasis on observation and a priori reasoning, developing early forms of the scientific method. The most notable innovations were in the field of optics and vision, which came from the works of many scientists like Ibn Saul, Al-Kindi, Ibn al-Haytham, Al-Farisi, and Avicenna. The most notable work was the Book of Optics, written by Ibn al-Haytham, in which he conclusively disproved the ancient Greek idea about vision, but also came up with a new theory. In the book, he presented a study of the phenomenon of the camera obscura and delved further into the way the eye itself works. Using dissections and the knowledge of previous scholars, he was able to begin to explain how light enters the eye. He asserted that the light ray is focused, but the actual explanation of how light projected to the back of the eye had to wait until 1604. His treatise on light explained the camera obscura hundreds of years before the modern development of photography. The 7-volume Book of Optics hugely influenced thinking across disciplines, from the theory of visual perception to the nature of perspective in medieval art. In both the East and the West, for more than 600 years, many later European scholars and fellow polymaths, from Robert Grosseteste and Leonardo da Vinci to René Descartes, Johannes Kepler, and Isaac Newton, were in his debt. Indeed, the influence of Ibn al-Haytham's optics ranks alongside that of Newton's work of the same title, published 700 years later. The translation of the Book of Optics had a huge impact on Europe. From it, later European scholars were able to build devices that replicated those Ibn al-Haytham had built and understand the way light works. From this, such important things as eyeglasses, magnifying glasses, telescopes, and cameras were developed.